Good morning, students. Today we discuss about chapter 4, principle of mathematical induction. In case of principle of mathematical induction, he always provide a statement to you and also give the net result. With the help of this result, we are able to calculate its solution directly. As you study in class 11th, the formula of AP 1 plus 2 plus 3 up to n, the result is directly calculated by the formula n into n plus 1 divided by 2. Similarly, PMI help us to calculate the direct formula for that one. This question can be done with the help of 3 steps. First step, we substitute value of n is equals to 1. If our result is true for n is equals to 1, then we can say it is also true for n is equals to k, where k is a some positive integer. Value of k may be 2, value of k may be 3, value of k may be 4, and so on. This result is true on the behalf of n is equals to 1. After that, we can go for the last step, that n is equals to k plus 1. If our result is true for n is equals to k, that we check is it is also true for n is equals to k plus 1. K plus 1 doesn't means 2 plus 1 equals to 3 or 3 plus 1 is equals to 4. K plus 1 means whenever you reach to the kth term and we want to discuss the result for the next term also. So k plus 1 indicate the next term. Now let us start the question. First step, a statement is given to you 1 square plus 2 square plus 3 square up to n square, and its result is n into n plus 1 into 2n plus 1 upon 6. Prove by the PMI where n belongs to natural number. Our first step, let n is equals to 1. So we substitute 1 in place of n. 1 square is equals to 1, 1 plus 1 2, 2 into 1 2 plus 1 3 upon 6. After simplification we get 1 is equals to 1. So we can say this result is true for n is equals to 1. Now we can consider if result is true for n is equals to 1, so that it is also true for n is equals to k. So let us substitute n is equals to k. In this place substitute n by k or replace n by k. In every place n you have replaced n by k. Now let us check for n is equals to k plus 1. This is a quite important step. In place of n we substitute k plus 1. K plus 1, k plus 1, k plus 1, and remember here, whenever a number is given to you in multiplication, then please keep the statement in bracket 2 into k plus 1. It is an important step. Now after simplification we get here k plus 1, we get here k plus 2, we get here 2k plus 2 plus 1, that will become 2k plus 3 upon 6. Now whenever you want to solve this question, remember you always start with the left hand side and reach up to the right hand side. Now I have take the left hand side, k plus 1 square here. Now see here, if it is a 3, it is 2, it is 1, means when I moving to the back side, the step is always reduced by 1. So if it is k plus 1, before that it is k square. K plus 1, one term reduced, then it become k square. Now substitute the value of 1 square plus 2 square plus 3 square up to k square given in the equation 1. It is equals to k into k plus 1 into 2k plus 1 upon 6. Substitute the value into this one, plus k plus 1 square as it is. Now take the LCM, and after that make a habit to solve the equation by taking common, not by the multiplication, not by the opening the square. Open the square only when it is the last option. Before that, if you observe something is common, take common and make the calculation in less amount, so that it will take less time to simplify. Now see, I have taken k plus 1 common here. What is left here? 1k is left, 2k plus 1 is left, 6 is left here, k plus 1 is common, 1k plus 1 is left. Now go for multiplication, 2k square plus k plus 6k plus 6. After that you will get 2k square plus 7k plus 6. Now it is a quadratic equation, so I can factorize by splitting its middle term. After factorization I will get k plus 2 and k plus 3 as a factor. If you observe, this is your right hand side. See the and compare the result with the right hand side. This result and this result. they are exactly same. So we can say it is true for n is equals to k plus 1 whenever it is true for n is equals to k. Listen here, result is true for n is equals to k plus 1 whenever it is true for n is equals to k. Means he want to say if result is true for n is equals to k, only then it is true for n is equals to k plus 1, where k is some positive integer for all n belongs to natural number.